Alright, so why in the world does taking a monomial to a power work? I'm going to talk about that for a second. Now, obviously, the shortcut right here is to distribute. If I multiply the 3 by each of the powers, that's what allows me to get my new exponents. But why does that work? I just want to talk about what does an exponent to the third power mean. Let's, instead of this big complicated monomial, here's a really easy monomial, 5. Let's say that 3x cubed times y to the second power was just 5. And instead I'm taking 5 to the third power. You know that this literally means 5 times 5 times 5, which gives us 125. Well, when we have something like this, it really is the same thing. This is really the quantity 3x cubed y to the second power times the quantity 3x cubed times y to the second power. One more time, 3x cubed times y to the second power. So when I multiply all of these together, you end up grouping things. And notice, if I group my 3's, how many do I have? Well, I have 3 3's. I have 3 times 3 times 3. How many x cubes do I have? I have 3 of them. In other words, I have 3 times 3 of them is 9, or 9 x's being multiplied together. Likewise, I have y squared times y squared times y squared. If you add the exponents, 2 times 2 times 2 is the same, or if you add them, 2 plus 2 plus 2 is the same thing as 2 times 3, which is just 6. In other words, this works just from the basic fact that when you add something a certain number of times, like 2 times 2 times 2, the shortcut for that is just to do 2 times however many you had, or 3. So, a quick trick for thinking about that, just multiply. If you have a power to a power, like x to the 4th to the 3rd power, you could do x to the 4th times x to the 4th times x to the 4th and add all the 4's together, or you could just do 3 times 4 and get x 12 straight away.